Hello, so this is A-Level Maths Tutor UK. In today's video, we're just going to look at this example here of where we've got this trig function, we've got the sum or the subtraction of this 12 sine x and this 5 cos x, and we want to find the maximum and minimum values of this sine and of this function here, so the 12x take away 5 cos x. We want to find the minimum and the maximum values of this function algebraically. So how could we do this? So, I mean, what some students may be tempted to do if this was like an exam question, is they may do this calculation here. So they may say that, okay, well, the maximum of sine x is 1. The minimum of cos x is -1, obviously. So when we think about like a sine and cos graph, obviously with a sine graph, goes like this, maximum 1, minimum 1. With the cos graph, again, very similar, just shifted across. Your maximum at 1, your minimum at -1. So some students may say, well, the maximum of sine is 1. Minimum of sine is -1. Minimum of cos is -1. Maximum of cos is 1. So they may say, okay, well, the maximum of 5 sine x take away 12 cos x. Well, to make this number as big as possible, I need this to be as big as possible. And then if I take away a number, I need this to be as small as possible, because a bigger number take away a smaller number gives me overall a bigger number. So kind of using upper and lower bounds essentially. So they may say, well, okay, well, the maximum of sine is 1. So 5 times 1 would give me 5. And then they may say, well, the minimum of cos is -1, and -1 times -12 gives me +12. So they may turn around and say, okay, so the maximum of this here must be 17. And they may do a similar calculation down here and they say, okay, well, the minimum of this, well, to make this as minimum as possible, they may say, well, okay, we need the minimum of sine. So we want this number to be as small as possible and this number to be as big as possible in order to make this minimum. Because again, if you want to minimize something, take away something, you want your first number to be as tiny as possible and the thing you take away to be as big as possible, so you get the tiniest number. So a student again may say, well, sine x, the minimum of that is -1. Let's put -1 there. And then they may say, well, the maximum of cos is 1. The minimum value there, take away the biggest possible value, gives me overall the smallest value. So they may say, well, this is -5, take away 12, so -17. So they may turn around and say, well, the maximum of this surely is 17, and the minimum of this surely is -17. But that is actually not correct. This is an incorrect calculation. So why is this incorrect? So let's think about what happens when we add or take away. I mean, it's the same thing as well if we take away the sine cos graphs, because I know in this example here, we're actually doing a subtraction here, but it's the same kind of idea. When you add and subtract sine and cos waves, or take a superposition of sine and cos waves, that's the technical term, taking a superposition of waves, what actually happens is that, yeah, when you add the maximum value of sine and the maximum value of cos together, so in this case they're both 1, you don't get the maximum value of sine plus cos. So if you do this cos wave plus this sine wave, you're not going to get the maximum value of cos plus the maximum value of sine, because they have different x coordinates. So you're adding all the y coordinates, the corresponding. So you're adding all of these y coordinates together. So you're adding that and that and that and that and that together, and that and that and that and that. You're adding the y values together. So we can clearly see, yeah, again, so we're adding the y values for every x value. So we're not doing the maximum value of x plus, sorry, maximum value of cos plus the maximum value of sine, because the maximum value of cos and the maximum value of sine occur at different x values. So we're not adding them together. So that's why we can't do this thing that we did here, where we want to do, we want to maximize this by just considering the maximum of the individual sine and cos waves, and then just adding those together. We can't do that when we take a superposition of waves, when we take an additional subtraction of cos and sine waves. So we can't do this. And the same for the minimum as well. Again, we can't do minimum of cos plus minimum of sine equals minimum of sine plus cos, because again, the minimum value of sine and the minimum value of cos, we can see from the graph. I mean, it's not a very good graph because they're not aligned properly. I mean, that should be -1 there, and that should align up there. We can see that the x values here are different when they both hit their minimum, both these functions here. So we can't do this. So we've got to do something else. So we've actually got to do what we did yesterday, where we were rewriting these the addition and the subtraction of sine and cos functions in terms of these two forms here. So r sine x plus alpha, where r was some like positive number and alpha was some random angle. We had to, so in yesterday, what we did was we looked at how we could convert these two forms here into this kind of form here where you've got like an addition and or a subtraction of a sine and a cos wave. So that's what we want to do here. And then once we can convert this into either one of these forms, we can then work out the maximum value and the minimum value by using these forms rather than just taking maximum and minimum values individually of the individual sine and cos waves, which would be incorrect as we just saw on the previous slide. So what are we going to do? So are we going to pick the r sine x plus alpha form, or are we going to pick the r cos x plus alpha form to do this specific calculation here? Well, it actually doesn't matter. I mean, unless the question tells you to do r sine x plus alpha or r cos x plus alpha, unless it tells you to write the expression that we had here into either one of these forms, you can pick either one. So it doesn't actually matter which one you go with, because you'll still get the same minimum and maximum values as your final result. So, I mean, in this question here, let's just use the sine x form. So let's write this again. Let's write this 5 sine x take away. Sorry, this should be a 12 here. My bad. Let me change this to a 12. So let's write this into the form r sine x plus alpha. So let's write this combination of sine and cos into a function just in terms of sine. So again, what we can do, very similar to what we did yesterday, is we can use the formula book, the addition angle formula book from the formula book. So the addition the sine addition formula, formula from formula book. So we're going to use that formula. So in this case, our A in our formula book, so our capital A in this case in the formula book would be x, and our capital B would be alpha. So just going to plug those into the formula book, and we get sine using the sine sum angle formula, or the sine double angle formula, however you like to think about it. It's going to get you a sine x times by cos alpha, so that's cos alpha, and then plus a sine alpha times by cos x. We can then now expand the brackets. We're going to get r sine x cos alpha plus r sine alpha times by cos x. And now what I'm going to do, very similar to the video yesterday, if you saw that one, is we're going to just write it like this instead. So r cos alpha times by sine x plus r sine alpha times by cos x. So why am I doing this? So because similar to what we did yesterday when we were proving why we can do this in the first place, is kind of r sine x alpha transformation. If we compare the sine x there and the sine x there, if this is equal to each other, then these coefficients here and here must match. So we know that 5 must be equal to r cos alpha. And we can do a very similar thing here. We can say, well, you've got cos x there, you've got cos x there. So this negative 12 coefficient there must be the same as this r sine alpha there. So negative 12 must be equal to r sine alpha. So then what we can do, very similar to yesterday, is we can kind of use this fact here to divide the second one by the first one. So r sine alpha divided by r cos alpha. Well, the r's are just going to cancel out, so we don't need to worry about the r's there. We get sine alpha over cos alpha. Well, that's going to be tan alpha. And that's going to be equal to r sine alpha, which was this minus 12. So this equals minus 12 divided by this 5 there. So then we can do that alpha is equal to tan inverse of minus 12 over 5. And if we do that on the calculator, so tan inverse in radians, make sure we're calculating radians. So minus 12 over 5, we will get this result here. So to let's just go with 3 significant figures. Actually, let's go with 4. So minus 1.176 Sorry, that should be a 6 there, and this is to 4 significant figures. Okay, so that's our alpha. So we've calculated what this alpha must be. So now let's calculate what this R value must be. So what's the R value going to be? So so again, what we can do, similar to yesterday, is we can square this here, we can square this here, square that, that becomes a squared, and then this becomes a squared here. So we know that R squared sine squared alpha, just by squaring this red part here, plus this part here to square the blue part squared, R squared cos squared alpha, that's going to be equal to, just by factorizing out the R squared, it's going to be equal to sine squared alpha plus cos squared alpha. And we know from our trig identity that sine squared plus cos squared is 1. So this is just an R squared. And this is going to be equal to these, the sum of these two numbers squared. So this is equal to, so this R squared that we got here, so R squared must be equal to 5 squared plus minus 12 squared. So 5 squared gives you 25, minus 12 squared is 144. You should get 169 if you do this. So you can square root 169 to get your R value, and so therefore R must be equal to 13. So R is 13, and alpha is minus 1.176. So therefore what we can conclude from here is that, if we just move this all up, so therefore we can say that 5 sine x subtract 12 cos x is exactly the same as 13 sine of x, and then alpha is negative 1.176, so negative 1.176. So we know that this must be true for a fact. So now then, how can we find the maximum and minimum values of this function here? So now we've converted what we wanted into the form R sine x plus alpha. And the question was, I mean, the original question back here was to actually find out what the maximum and minimum values of this are. So now we've converted it into this form, we can actually do that, because now we can focus on this sine function that we got on the right hand side here. So what would be the maximum and the minimum values of this sine function? So a sine wave, regardless of whether you shift it to the right or to the left, always has a maximum 1 and a minimum of -1. So I mean, what you're doing here is you're doing x take away 1.176. So this is just a translation. Let's just make this really clear, that this is a translation by vector. So you're translating the sine graph. So translation of y equals sine x by a vector of positive 1.76. Because remember, if you're taking away a value from x within the sine function, you're shifting it to the right. So you're doing a vector of this. So when you shift a sine graph to the right, you're not changing the maximum and the minimum values of that sine graph. So again, a sine graph like this, you're going to shift it to the right a little bit. You're not changing the maximum and the minimum values. They're still going to be 1. So we know for a fact that the maximum value of this sine function here, so we know that max of this sine x take away 1.176, I mean, it should still just be, well, it is still going to be 1. So the maximum value of this is 1, times that by 13. That means that the max value of this 13 sine x take away 1.176 is going to be 13. So 13 times by 1. So the maximum value of that graph is 13. And so by using a very similar bit of logic, it means that the minimum value of that is going to be negative 13, because again, the minimum value of this translated sine graph is still -1. So the minimum value of this 13 times by sine x minus 1.176, sorry, 1.176, that is going to be 13 times by -1, and that's -13. So the minimum value of this 5 sine x take away 12 cos x is -13, and the maximum value is 13. So that's what our calculations show us. So we've now actually calculated the real answer. It's not 17, and -17 is what this would suggest back here. The correct answer is going to be 13 and -13. So that's how we can do a calculation like that. We want to convert it into one of these forms here. So either R sine x plus alpha or r cos x plus alpha. And then once we do that, we can just basically say that our maximum value is going to be r and our minimum value is going to be negative r. So that's kind of the idea with these kind of problems. Or alternatively, something I'll just say is that you can use the formula that we derived yesterday in video 112. So in that video from yesterday, you can actually just memorize that formula. So the formula that we had for the sine x plus alpha one, there was also an r cos x plus alpha formula too. But in this question, if we just use the sine x plus alpha formula, it was this one here. So if a times sine x plus b times cos x is equal to this, it means that r is equal to the square root of a squared plus b squared, and alpha is equal to tan inverse of b, so the coefficient of cos x divided by the coefficient of sine x. So we can do the calculation using the formula here if you prefer memorizing this formula. So in this case, if we've got this 5 sine x take away 12 cos x, the a is 5, so the coefficient of sine, the b is minus 12, the coefficient of cos. So r is going to be the square root of a squared plus b squared, which is the square root of 5 squared plus minus 12 squared, which is equal to, again, the square root of 169, which is equal to 13. So we get the same thing as before. And the alpha, so in this case, when we want to write this linear combination of sine and cos in terms of sine, in terms of a sine translated function, it's tan inverse of b over a. So it's tan inverse of minus 12 over 5. And if we do that on the calculator, we get the same thing as we got before. We get minus 1.176 to 4 significant figures. So again, that means that therefore this is equal to 13 times by sine x minus 1.176. And also, I mean, if you wanted to use the other formula that we looked at yesterday, so the other formula was this one. So I'll just write this here. So other formula using cos instead. So other formula. So it was this one. So if you've got a sine x plus b cos x, and that's equal to r cos x plus alpha this time instead, then the formula was this. So again, r is the square root of a squared plus b squared. So regardless of whether you want to write it in terms of sine or cos, it's always a squared plus b squared square rooted for your r value. But your alpha value this time, if you're going to write it in terms of cos, was this instead. So instead, it was tan inverse of negative a over b this time instead. So if you wanted to write this in terms of cos instead, your r value is still going to be 13, but your new alpha value for the cos expression, so remember a was still 5, so you still got 5 there, using this there. B is still negative 12, so b negative 12. So we can plug this into here, so we get tan inverse of negative a, so negative 5, over b, which is sorry, I forgot the equal sign there, negative 12. So that's going to be tan inverse of 5 over 12. We can put that into our calculator, tan inverse 5 over 12. That would get us 0.39523 significant figures. And so therefore what we can say is that the expression that we had before, so therefore I'll do this in black ink. So yeah, 5 sine x take away 12 cos x is exactly the same as 13 cos of x plus 0.395. So you can write it like this if you want to as well. And again, the maximum value of this graph here is going to be 13. The minimum function, sorry, the minimum value of this function here will be minus 13, because again, the maximum value of cos is 1, minimum value of cos is minus 1. And so yeah, so we can say that actually this is just the same as 13 times by sine x. Take away the value that we got back here, this 1.176. 1.176. So these are actually the same thing. So yeah, that's kind of a summary of how we can actually use these r sine x plus alpha and r cos x plus alpha identities, I guess, to work out maximum and minimum values of the sum and the subtraction of sine x and cos x functions. So yeah, that's all I wanted to look at today. Any questions and comments, just write it in the comments below.